हेलो गाइस, आपका स्वागत है हमारे चैनल पे लेट्स लर्न विद अस पे। तो इन टुडे वीडियो वी गोना डिस्कस अबाउट पाइथन doubt debunking code learning. Okay, so we gonna just debunk some queries and some questions which are being arises in most of the student mind during understanding Python. Even you can see in my videos of Python, you can see there are so many things which I discuss, but here are some the things I want to really discuss. So this video is gonna be long, so stick to the video and we're gonna find out so many important things in it. And I can say that this video, okay, especially this video is very important if you really want to understand, or if you really want to uh, stay in the Python, because it really open your mind, because there are so many concepts which are not discussed deeply in other videos. So this video is definitely gonna help you. Okay, now we're gonna start. So what is py ideally? Okay, so basically py means Python. So ideally basically full form is integrated development and learning environment. Again, integrated development learning environment, so basically is a simple and lightweight environment provided with Python for writing, debugging and running Python code. It is particularly suited for beginners and small scale project due to its ease of use and basic features. तो जो की फीचर्स हैं वो है आपका इंटरेक्टिव सेल्स, अलाउ डायरेक्ट एग्जीक्यूशन ऑफ पाइथन कमांड्स, प्लस यूजफुल फॉर टेस्टिंग कोड्स स्निपेट interactively. Okay. Second thing is that editor window provide a text editor to write and save Python script with syntax highlighting and auto indentation. So even in Python ideally you have given auto indentation, plus there is support multiple files with tabbed browsing in it. Now third point is debugger. Okay, included a debugger with stepping breakpoint and call stack visibility for error tracking. So in debugger you can track the error and do many more things. Then fourth point is output console, display output and error generated by the program. This also done by Python ideally. Fifth point is cross platform. So because of using the ideally you can get the features on Windows, Mac OS and Linux as part of standard Python distribution. Okay, so now you get what really is Python ideally. Now second question is different between script and interactive mode in Python. Now again a question raised in your mind: what if I give you answer in just one line? So script is basically where you save the file, a large file where you have to just save the file by its name and run it separately. But in interactive mode you can just write a is equal to 5, b is equal to 10, then print 5 plus 10. Okay, so you get the answer. Interactive mode, just you use to test the logic. Okay, in faster mode you are not saving the code, you are just running it fastly. For that reason we using interactive mode. Okay, this is the same thing I write in this doc file. So in script mode Python code is written and saved in a .py file. Interactive mode is not saved. In interactive mode you write and execute code directly in the Python shell or console. There is no need to save the code. And it run line by line execution. Each command or line of code is executed immediately after you type it, and making it useful for quick test and experimentation. No file the code is not saved unless you manually copy and paste it into the script file. So this is the thing. Now one question also came to me by a student: sir, what is the difference between save and save as? So basically save, when you already save the file and it overwrite the new version. Okay, so for example you write something as in that doc file, so when you press the Ctrl S, okay, is it override the file with that information. But in save as, if you want to change or change the name, or if you want to change the different location, you can press the, from file section, you go to the save as section, and it gonna change the file name or file location. Now what is the meaning of foregoing process? So the term foregoing process refer to the process or step that has just been described or mentioned before the current statement. In other word, it means the step or explanation given earlier. Means if explanation or steps are been explained in earlier time, then it is known as foregoing process. For example, if you read an explanation and then encounter the phrase as shown in the foregoing process, it means as shown in the process I just explained. So basically what they explain, it is being there. Okay, now so many people comment in video that what really is advantage of interpreter. Okay, now you have to know that Python is interpreted, not compiled. What is mean by that? Python code is not compiled into machine code specific to an operating system. Instead, Python code is translated into byte code, a platform independent representation. So what happen is that Python code is not compiled directly to machine code. Rather, it convert to byte code, and byte code is just converted by PVM or read by PVM, which is Python virtual machine, or you can run it in any machine. You basically took this byte code and run it any machine, either it is Linux, either it is Unix or Mac operating system or any other. Okay, you just need to install their Python virtual machine and you are ready to go. Okay, now the first advantage of bytecode that it is platform independent, as I say, because it convert into bytecode, and this code which really run on multiple platforms. So okay, now easy to debugging. Interpreter execute code by line and making it easier to spot and fix error as they occur. You don't have to compile the entire program to see if it works. You can test small section incrementally. Okay, now interactive execution. Interpreter allow for interactive execution, which is useful for learning and experimenting. Now another question is why you have to run Python same code into different platform like Unix and compile entire program again. So what is the need that Python same code you have to run on Unix? So Python is not as I say, it is. So how really it works, you explain here. When you write a Python code, the interpreter convert into bytecode, a low level platform independent version of the code. Now this bytecode is then executed by Python virtual machine PVM, as I said earlier. So don't need to compile Python code for the each platform. Just need to write an interpreter for the Unix, Windows, etc. system, and it will run the Python code. Okay. Now what is the difference between compile language versus Python interpreted? Okay, so compile language, for example, in C or C++, source code, which is the code you have written, is translated into machine code. Okay, 0 and 1 directly, which is all specific to operating system and hardware. So you cannot just run that machine code into another Unix or Linux. Okay, but there is difference between Python, as Python bytecode can be run in any platform. You just need a Python virtual machine and it is ready to go. Now we get some main difference. So bytecode is simply intermediate representation between the high level programming language like Python and Java and machine code. It is not directly understandable by hardware, but it is more abstract and platform independent. Okay, so it is not directly understood by hardware, but it is more abstract and platform independent. And this thing you have to know. Now how it works. Bytecode is typically executed by a virtual machine, Python PVM or Java JVM, okay, which translate it into machine code at runtime. For example, Python code is first converted to bytecode and then the Python virtual machine execute that byte code. Now platform independence, bytecode is the same across different platform. Example, python.pyc file is compiled Python file, or java.class file is compiled Java file. Example of bytecode. So if you want to know the how Python bytecode file is saved, so python .pyc file is a Python bytecode file. Okay. Now what really is low level language, also like assembly language, is one step above machine code, but it is closely related to the hardware. Okay. Now it is usually assembly language which provide a more readable version of machine code using mnemonic symbols. So how it works: low level language require a assembler to convert the assembly code into machine code. Each instruction in low level language directly correspond to machine instruction. Okay. Now platform independence, low level language are hardware specific. So assemble code written for one CPU architecture won't work on another without modification. These things you have to know in advance before you go for assembly. So example assembly instruction like mov, add, subtract, ठीक है, which are directly mapped machine instruction are example of low level code. Now third point, machine code. So what it is, machine code is the lowest level representation of program made for binary instruction 1 and 0 that is CPU directly executed. Okay. Now in machine code you directly know that it is already in lowest form, 1 and 0 form, binary form. Don't need separately anything. So this is the code that is directly processed by CPU. It is completely hardware specific. Now one thing you have to note in your mind that so in many student mind the question arises that if a code which is being translated into binary instruction 0 1 and 0, so why it cannot run on multiple platform? The thing is that when you translate or when you convert when you compile the code based on machine code or binary instruction 1 and 0, so it is being converted directly specific to that hardware, specific to that CPU. Okay. Now when you change the hardware, when you change the CPU, it gonna change, it gonna not work on the same way that work in on the previous version of computer. Okay. So this thing you have to know in your mind. But what the difference between the Python? In Python, basically what happened is that it converted into bytecode. So bytecode is basically not dependent on the hardware. It is just a medium or immediate conversion of the Python code. Okay. Now what JVM is do? JVM connector or JVM really know what is the hardware and what is the thing. Based on that, it convert that bytecode pyc file to specific machine code 0 and 1. Okay. So this is the advantage of Python bytecode or Python JVM. Okay. So platform dependence, machine code is highly platform specific. So this thing you have to know. The machine code for a program running on Intel x86 processor will be different from ARM processor. So this very important thing you have to know. If your processor, if for example Intel processor generation 6, and if a machine code run on it, and if you try to run it on another processor, for example Intel core processor 9 or 10 or 11, it not gonna work on all those processor. Okay. For that you have to need another processor. For that you have to just compile the code on them separately. So this is the thing. So binary instruction look like 1011 like that. Okay. As I explained earlier. So this thing we already cover how Python convert code into bytecode. It is very easy. What really is PVM? As I said, PVM is the Python virtual machine. It's a component Python interpreter that can execute bytecode generated from Python source code. So it's responsible for running the Python program by interpreting the bytecode and translating it into machine level language instruction for underlying hardware. Here how PVM works: source code to bytecode. When you run a Python program, the Python interpreter first compile the Python source code .pv file into bytecode intermediate code. PVM execute bytecode. The PVM then takes this bytecode and execute it line by line. It read the bytecode, interpret it, and carry out instruction by communicating with the computer hardware. Okay, so this is how PVM works. So why is bytecode platform independent? As I said earlier, the main function or the main work is done by PVM, which basically do the work. Because of that, bytecode is platform independent. How a bytecode look like? So how really it look like? So it doesn't look like a typical source code, but rather consist of numeric or symbolic instruction that are not directly human readable. For example, Python bytecode is stored in .pyc file, as I studied earlier, and can be viewed using a dissembler. Okay, so you have a dissembler module by which you can see how a pyc file look like, which help you to see the bytecode look like in human readable format. Because for computer readable format, it gonna be complex. So if you really want to read in human readable format, you have to just need a dissembler, which is also represented by dis. So the bytecode is a sequence of instruction like load underscore fast, comma store underscore fast, binary underscore add, etc. Okay, so this is the example of a simple program. For example, a function def add a comma b, return a plus b, or print add 3 comma 5. Okay, so this is the example of basically dissembler or bytecode. So this add 0 load fast, and so these are the function which running in backend. Okay, so this is a raw bytecode for advanced user, for example, who understand things. This is the raw form without this dissembler. Okay, in raw form it look like this. So how machine code look like? The next question arises. We see the bytecode. So we also want to know how the machine code it look like. So machine code is nothing. It is a 0 and 1 binary format. Okay, nothing more to that. But there is some common extension for file containing machine code. For example, .exe, as you see in multiple games or in multiple files, .exe file is there. Okay, so it is a binary executable file that contain machine code read by ready to run by operating system. These files are commonly used in Windows and contain instruction directly executable by CPU. Second point is that .binary. So binary generic .bin file is a generic binary file that can contain raw machine code. It often used for firmware, low-level software, or any kind of binary data. So this is a .binary or .bin. So it is generic binary file that contains raw machine code. Okay, often used for firmware or low-level software or any kind of binary data. Now third point is .elf. Okay, it is an executable and linkable format for Unix and Linux. So an .elf file is a common format used in Unix or Linux system for executable object code, shared libraries, and code dumps. It contains machine code as well as metadata needed for operating system to execute it. Okay, now fourth point is .o object file or Unix or Linux. .o files are object file typically generated as intermediate output during compilation process. Okay, so when there is a compilation process, .o file object files are being created. They contain machine code that are not yet been linked into fully executable. Okay, so these are the machine code that are not typically fully linked to full executable. Now fifth point is .dll dynamic link library, which is for Windows. So .dll file contain machine code that can be loaded and executed by program at runtime. It's similar to an executable, but it is designed to used as a library by other programs rather than directly rather than run directly. Okay, so this is the .dll file. Now 6 point .so share object, basically full form is share object. So basically it is used for Unix or Linux, similar to .dll file in Windows, and .so file shared object file is shared object file on Linux or Unix system that contain machine code as library. Okay, so this is same as .dll but used for Unix or Linux. Now these are things which are common. In next video we're gonna talk about does in Python code we follow ASI or Unicode, etc, etc. If you like this video, share and subscribe and comment down if you get any information from this video, or if you don't like video you can just comment down how we're gonna improve our video, what we have to just improve and what we have to do to improve our video. So let's see you in next video. Till then, see you, tata, bye bye, and thank you for watching our video. Thank you.